All right, let's jump right in. We're going to talk about the absolute bedrock of our digital world, the secret language that, believe it or not, powers every single device you own.
But first, I want you to really think about this question for a second. Every photo you've ever taken, every show you've streamed, every single app on your phone, could all of that, all that complexity, really just come from two simple digits?
The answer is yes. That's it. It's kind of hard to wrap your head around, isn't it? But it's true. The entire digital universe, in all its glory, is built from a constant, lightning-fast stream of zeros and ones. That's the whole shebang.
So how on earth does that even work? Well, it all comes down to a really basic truth about how machines think. This is their secret language.
See, computers don't understand words or pictures or sounds the way you and I do. They process everything through a system that is incredibly simple, but also unbelievably powerful. This code is how they translate our world into theirs.
And you know, the real genius of this whole system is just how simple it is. It's all based on the most basic concept you can possibly imagine, a simple on or off switch.
Okay, so we humans use what's called a base 10 system. That just means we have 10 digits to work with, 0 through 9. But computers, they use a base 2 system. They only get 2 digits to play with, 0 and 1.
And this base 2 system, it has a name, binary. Honestly, the best way to get this concept is to just think of a light switch, right? It can only be in one of two states, on or off. There is no in between.
And this is what's so cool. That analogy maps directly to the code. And the tiny circuits inside a computer, on, where electricity is flowing, is represented by the number 1. And off, no electricity, is represented by the number 0. It's literally that straightforward.
So here's the kicker. It's all about scale. One switch on its own can't do much. But your computer has billions, with a B, of microscopic little switches called transistors, all flipping on and off at insane speeds. That is how they work their magic.
So let's get into how this actually builds up. How do we get from a simple on or off to you streaming your favorite movie? Well, it's all about how you combine those zeros and ones.
And that's the big question, isn't it? If all you have are two options, a 0 and a 1, how can that possibly be enough to represent all the numbers, letters, colors, and sounds in the entire world?
It's all about putting them in the right order. Look, it's easy at first. 0 is just 0, and 1 is just 1. But to represent our number 2, a computer runs out of digits, so it just adds a new column and writes 10. For our number 3, it's 11. For 4, it's 100. See the pattern? Just by arranging zeros and ones, we can represent any number you can think of.
But here's where it gets really powerful. This same idea applies to, well, everything else. This isn't just a number system, it's an information system. By agreeing on a standard, we can give a unique binary code to every single letter of the alphabet.
And this shows you exactly how it works. Using a standard called ASCII, the capital letter A is always represented by this specific 8-digit binary sequence. B has its own unique code. In fact, every single character on your keyboard has a special binary number just for it.
This is my absolute favorite way to think about it. Imagine you have a bottomless bin of Lego blocks, but you only have two kinds, say red ones and blue ones. At first, that sounds kind of limiting, right? But you'd quickly realize you can combine them to build anything, a car, a castle, a whole city. Binary is exactly like that, but for information.
So, why does any of this matter to you? Because once you get this one simple principle, you start to see that this code isn't just trapped inside your computer. Binary is, quite literally, everywhere.
Every single digital thing you do is, at its core, just a massive, high-speed conversation of zeros and ones. That text message that just popped up on your friend's phone, that's a stream of binary that flew through the air. The show you're watching right now is just light and sound being perfectly rebuilt from this simple code.
I mean, think about it. Your computer, your smartphone, your digital camera, your video games, the entire internet itself. Every single piece of modern tech you rely on is built on this beautiful, simple, 2-digit foundation.
It always comes back to this. Just two states, on and off, 0 and 1. And you know, this simplicity is exactly what makes it so tough and reliable. For the first computers, it was way easier to tell the difference between on and off than it was to try and measure 10 different levels of electricity. An on signal is clearly not an off signal. It's that rock-solid reliability that makes binary the king.
And that leaves us with a pretty mind-bending question to think about.
We have built our entire modern civilization on just 2 digits. So as we look ahead to wild ideas like quantum computing, where a bit can be both a 0 and a 1 at the exact same time, it really makes you wonder, what new language will we discover next, and what unimaginable worlds will that language let us build?